What is a digital signal? And digital signals in communication, how are we going to define it? The best way to define the digital signal is that it is not an analog signal, because digital signal only comes from the analog signal only. This has to be very clear. Digital signals, they are discrete or non-continuous. Analog signals are continuous and non-discrete. So digital signals are not analog signals, because digital signals, they are non-continuous. You will not get infinite values, or you will not get at every t v value. It is discrete because it will be a simple value or a proper value for certain say range of values. Okay, so digital signals are represented in binary form. This is very important. 0 1 0 1 0 1 like this. And the binary form, let me show you here that this is a value. You can take it as a voltage. Here you can take it as a time. Now voltage and time, if you see, it will be like this. For some t it will be some voltage. From some t it is this voltage, some t this is voltage. So these are actually the discreteness or non-continuity of the digital signal. So in this analog signal, if you take some samples, quantize it, that will actually form a digital signal. So digital signals are represented in 0 1 0 1 form, binary form, and are consist of different values of voltage at discrete instant of time. So a digital signal is discontinuous. So if you take here, this is 0, this is 1, this is 0 0, then 1. So I am representing that graph. That is, it can take only two values, 0 and 1. It can be low and high voltage electrical impulses. Okay, so you are not getting an infinite values here. Only one value for one range. That is for one x, one y. Only 0 or 1 you are getting, nothing else. For example, you have a switch in your house. Just press it on, press it off. So on and off, 0 and 1, only these are the values which are possible in this digital case. Okay. So the receiving party, if it gets 0, it will say, oh, I got a 0 volt. When it gets a plus 5 volt, it will get, oh, I got a 1. Okay. So the analog signals can be defined using the phase, amplitude and frequency. In the similar way, not that much, but in the similar way, digital signals can be broken into sine waves, and these are called harmonics. Okay, wave, when you stretch it, it will become a straight line, and straight line here is representing only the digital signal. So you see in this picture or the animation, these are the harmonics being made from the digital signals. So like analog signals, digital signals can also have amplitude, frequency and phase. Sometimes people say, oh, analog signal only have these properties. No. Analog only forms digital. Digital only comes from analog only. You cannot have digital directly. Okay. So we can define the digital signal by two terms, because analog signals are defined by amplitude, frequency and phase. But the digital signals are defined by their own feature, because we are talking about bits here, 0 and 1. So we are talking about bit interval as well as the bit rate. So we can define the digital signal by two things: bit interval as well as the bit rate. 0 1 0 1 in different form are different digital signals, nothing else. What is the bit interval? This is the time required to send one single bit. Okay, from 0 is going, 1 is going, if you are sending it, conveying a message. So this bit interval is nothing but the time required to transmit a single bit. Okay, so this is the bit interval. And what is the bit rate? Bit rate is the number of bit interval per second. In this case, if you actually calculate or compute it, it is 8 bits per second. This means the bit rate is the number of bits sent in 1 second, BPS, 8 BPS. So the frequency of bit interval is the bit rate in digital signals. Okay, we'll talk about bit interval and bit rate, but for your understanding, this is the parameters used to define the digital signal. The next thing comes here is, with digital signal, we are using an audio signal to transmit numbers. As I said, we are actually using analog signals only, but these analog signals are used to transmit the numbers, actually conveying the message, conveying the information. So you cannot transfer the numbers digitally. You have to convert it into bits. So if you have a 6 number, you want to transmit it, it has to be converted into bits, and these bits are then transmitted in the way it has to be conveyed. So a digital signal uses some or the other physical property, for example, a voltage on the y-axis, a time on the x-axis, or the current on y-axis, on the time on the x-axis. So if you are sending, say, 0, that means you are sending 0 volt. If you are sending 1, you are sending the 5 volts. So the whole theory is only about the voltages, nothing else. Okay, there are no 1010, there are only voltages. So if you are sending 6, let me convert it into binary. So 6, 2, 3 are 6, 2, 1 are 2. So you get 110. So the binary conversion of 6 is 110. So if you want to send 6, you are actually sending 110. These are converted to bits, and this has to be transmitted. So we then first we have to decide what high means. We say plus 5 volt means 1. We say 0 volt means it will be 0. So first we have to decide. It is not 5 volt. It can be 4 volt also. It can be 6 volt also. So a 6 is 2 highs because 2 ones are there. So 2 5 voltages have to be sent, and then 1 0 voltage, that is 1 low value. So this is first one, this is second one, and this is the third 0. So you can say that plus 5 volt, and then any other voltage minus, it is not there always because there is nothing called minus voltage. It is just for representation to make you understand this is how it is being said. Now these boxes are to represent, that is why we call that digital signals are square waves. It is not. They are just pulses. They are only the voltages. Okay. Now the next thing is digital signals, as opposed to the analog signal, they are more resistant to noise. So the distortion or the attenuation is lesser as compared to the analog signal. Analog signals, they are more susceptible to the distortion because of the hindrance of the natural parameters like the noise. So these waves are simple to transmit. They are more reliable, unlike as opposed to the analog waves. So you are having a digital watch in your hand, that is actually having the digital signal. Devices like CDs, DVDs, obsolete now. And the computer, the buses inside your computer, the buses or the wires outside your computer, all are transmitting and getting the digital signal only.